The intensity of light travelling through a medium decreases due to scattering and absorption. The intensity of light, I, after travelling a distance of x centimetres through a soft tissue sample, is given by I is equal to I naught e to the 0.75x, where I naught is the initial light intensity. What percentage of the initial light intensity remains after the light has travelled 1 centimetre through the tissue? So if we have I over I naught, remember this is the initial, that's going to be equal to e to the negative 0.75 times 1, since it's travelled 1 centimetre. So we need to calculate e to the negative 0.75. And that gives us 0.4724. We want this as a percentage, so it's going to be 47.24%. After how many centimetres will the light intensity have reached 1/4 of its initial value? In other words, when I is equal to 0.25 I naught. So for that to happen, if we substitute in here, we get 0.25 I naught is equal to I naught e to the negative 0.75x, and the I naughts cancel. So we're looking to solve e to the negative 0.75x is equal to 0.25. So we can just solve for that on the calculator. E to the negative 0.75x is equal to 0.25. And that gives me 1.85 centimetres. So we're asked to determine an expression for ln I over I naught, and hence plot ln I over I naught versus x on the axis below. So we know that I was equal to I naught e to the negative 0.75x. I over I naught is equal to e to the negative 0.75x. Take natural log of each side, and we have ln I over I naught is equal to ln e to the negative 0.75x. So we have a log law that says we can write this as negative 0.75x. Sorry, I don't want an equals there. There's ln e. And of course, ln is log to the base e. Log to the base e of e, this part is just 1. And so that's negative 0.75x. So we have x on this axis, and our y is essentially the ln I over I naught. And negative 0.75 would be the gradient. And of course, there's no constant here, so it's going to go through the origin. We need another point. So if we take, say, x is equal to 4, then 0.75, negative 0.75 times 4 would be equal to negative 3. And so for negative 3 is going to be a point on our line. And then we just need to draw a straight line going like so. The intensity of light passing through a different type of soft tissue satisfies the equation I equals I naught e to the negative mu x. where mu is the attenuation constant. Light intensity measurements were made on a sample of soft tissue and the results plotted in the graph below. So it's similar to the graph we had above with a different gradient. We can see that this is 6 and -3. So it looks like the gradient here, being rise over run, is -3 over 6, which is -0.5. Use the graph to determine the value of the attenuation constant mu. So we just found the gradient was -0.5. Now we noted that this was a similar type of thing to what we had up here. So we have that ln I over I naught is equal to -mu x in this situation. And we just found that this would be -0.5 in here, making the value of mu equal to 0.5. We now want to express the equation I equals I naught e to the -0.75x using base 10, i.e. in the form I equals I naught 10 to the -bx. State the value of b to 3 decimal places. We have I over I naught is e to the -0.75x. Let's take logs, but this time to the base 10 of each side. So log I over I naught is going to be log e to the 0.75x. Again, we can use a log law. So we have log I over I naught is -0.75x log e, but of course that's log to the base 10 of e now, so it doesn't just become 1. Let's take 10 to the x of each side, and then we have I over I naught is equal to 10 to the -0.75 log e times x. And so I will be equal to I naught 10 to the -bx, where b is equal to 0.75 times log to the base 10 of e. So let's calculate the value of b as we're asked to do in the question. So b is going to be 0.75 multiplied by log to the base 10 of e to the 1, and that gives me 0.326, correct to 3 decimal places as required. Describe the change in intensity over a distance of 1 over b centimeters. So I is equal to I naught 10 to the -bx. If we take x is equal to 1 over b, I is equal to I naught 10 to the -b times 1 over b, and that's going to be I naught 10 to the -1, or 0.1 I naught. So we can see from there that it's 10% of the original value.